We have plenty on our agenda for today. Let's start with project updates. There is one update planned from Giuseppe. Giuseppe, are you here?
Yeah, I'm here. Just a very quick update. We released a new patch. Oh, can you hear me, by the way?
Can hear you.
Yeah, we can.
Okay. Yeah, just quick update. We released a new patch for JobSet. It's version 091. It's basically fixing a bug in JobSet that we found. So yeah, please check it out, and that's it.
Okay, thank you. Any questions to that announcement?
I guess to add one thing, I forgot to add it to the agenda, but we are talking about doing a 0.10 release to intake a feature. I think we'll probably support both 0.9 and 0.10, but it's just the other update.
Okay. If no more questions, comments, then the next person is Michał Wysokiński, who, as I can see, is not here yet. Next person in the line is Ami.
Yeah. Okay. So if we click on that link, it's just like a conversation for the fix for the fair sharing rounding bug. I just wanted to, is Yuki here by any chance? Let me see. No. Okay. I'll message over Slack, but I want to clarify. Oh,
I'm here.
Oh, I think you're working. Yeah. Did Michal clarify do you feel comfortable with the float number thing? Because I didn't quite understand from the conversation if there would still be preemption issues if we're moving away from int bucketing. Or like if the int bucketings prevented some sort of like preemption cycling, but then I saw the proofing that I feel comfortable with. But I just wanted to make sure that like this conversation was clarified because it's important to me.
Yeah. So this my comment just mentioned about another corner case. So actually in this PL, Gabe fixed maybe corner cases that you faced. But sometimes I can imagine another corner case, as I mentioned in the thread. However, we decided not to resolve this corner case. This corner case mean my mentioned corner case because my mentioned corner case probably probably does not occur in many environments. Does that sound good to you?
Yeah. Sorry, the thread is a little bit long. I'll sync offline, but as long as I just want to make sure that there's something that we're not thinking of, so that we can recognize if it happens in production. All right, thank you so much for your input. I appreciate it.
Yeah, sure. Yeah, we can sync in Slack or something else. Yep.
Sounds good.
Any questions, comments to that issue? I take this silence as no. So Michał has joined. Michał, update on KubeCon. Michał Wysokiński.
Sorry, what update would you like to hear about KubeCon?
I don't know. You are on the agenda in the first place.
Oh, yeah, got it. Yeah, I think it was like from the last time, like in the last minute of the meeting, like we were discussing that like we had the booth, or we have the booth, so we should organize it. And yeah, I don't think like we discussed it further. Plus, I don't think like we've done anything in the last 2 weeks to kind of organize the shifts. But the last time we talked, and again, it was like over time already, like people kind of expressed interest in attending the booth. So I think what we are going to do is this week we are going to send out like some spreadsheet with the proposed shifts for the booth, and whoever's attending KubeCon, please sign up. Please, let's meet. Maybe I would propose that we should have like some outing, or we even discussed like preliminarily with Yuki to maybe have some kind of like small workshop and meetup like for the working group, like to brainstorm and work together. So nothing concrete. I'm going to send out something, and yeah, please sign up, please attend, and let's meet and work together in a couple of weeks.
Okay, so I guess you'll be sending a form on a batch working group Slack channel, right?
Yes, and through the email to make sure it reaches everyone.
Okay, cool. Any questions to the topic? I assume that means no. Giuseppe, in-place restarts.
Yeah. Can you enable screen sharing?
Sure. I made you a co-host. You should be able to share your screen now.
Okay, thank you. Yeah, I'm able to share. So basically, I wanted to announce this new design for this feature of in-place for this feature of job set. The feature is called in-place restart. And my idea here is basically to give like a quick introduction of the design. It's like really long document, but that's because like there are a lot of examples and diagrams. And the idea here is basically just like give a quick taste so that you can check the document at your own pace and leave feedback and comments. But of course, while I give this quick introduction, just feel free to ask any questions or make any comments now. I'm more than happy to answer them. So yeah, starting with this, again, very quick introduction. I'll be mindful that there are other topics that we have to cover in this meeting. Is starting with some context, a pattern that is really, really common in JobSet is training machine learning models. And for the specific pattern, basically what we have is we create one worker process for each worker node that we have available. And these worker processes have to coordinate to perform the training. And since they are coordinating, if anything bad happens, and this kind of due to how these processes are structured, they cannot continue the training. They have to we have to restart every single one of them so that they can load the latest checkpoint and resume training from this latest checkpoint. And this in like just getting job sets sample here, this kind of looks like the following. We have this annotation to make sure we have one job for each node pool. And this is like a specific example for TPUs in GK, but again, just give a quick taste of how this looks like. And we also have this part here to make sure that we have one worker pod for each node. And we have this part, oops, Okay, I'm back. And we have this part here, which is basically setting backup limit equals 0 to make sure that we have this restart logic in place. And that's because the following: if a pod fails, maybe because its worker container failed, this is gonna trigger, this is gonna make its parent job to fail, because again, backup limit is equal to 0. And this is gonna make all jobs to be recreated because it's gonna trigger the job set restart. And this process of, if anything fails, just recreate all the pods, it works in practice. It really does. But when we reach a large scale, so think at least 1,000 nodes, this becomes very costly. So for instance, I do some math here, and for 10,000 nodes, I end up with a value of $1 million per month for just this overhead of recreating all pods for any failure. And this is basically because, like, the larger the scale, the more things exist that can fail. That means that failures happen more often. The larger the scale, there are more things to restart, which means that restarts take longer, and you're also more likely to use more expensive hardware if you're at this scale. So again, recreating all pods work, but it's expensive. So the main plan here, the main idea is, since recreating pods takes a lot of time for this scale, what if we just keep the pods running in their nodes and restart the containers while the pod is running? And I have here a comparison. The first one is simply recreating the pod. That is, if a container fails, just recreate the whole pod. The next case is using restart policy on failure. That is, if a container fails, just restart this container, and this already exists. But we have Yuan Wang here on the call. He did some work for this restart policy rules API, and he's doing also more work to release this new restart pod action. And the basic idea is that instead of only making it possible to restart the container that failed, it will be possible soon to, if a container fails, restart the whole pod in place. That is, terminate all the containers and restart them in order, as if the pod had just started running for the first time. So since we have this incoming feature, restart pod, we have a way for restarting pods in place, which make the process really fast. And like later in the document, I go over a benchmark. Basically, I use 5,000 nodes, which in this case, it's 5,000 pods because it's one worker per pod. For the case of recreating all pods to recover from failures, in my test, this process takes roughly 2 minutes. Whereas if I just restart the containers in place using a prototype for this design, it took 13 seconds. So we have basically a speed up of 2 minutes here. And the larger the scale, the larger this speed up for my tests. So yeah, coming back. Okay, great. We will have a way to restart the whole pod in place. The question now is, how can it be done in a workload? So, well, if we are talking about the pod that contains the original failure, this is fairly straightforward. If the worker container, that is the container running the process responsible for training, fails, we can just set in the pod spec to make sure that the whole pod is restarted in place if that happens. The problem is, how can we make sure all the other pods in the workload are also restarted in place because of this original failure. And what we're proposing here is basically adding this agent sidecar to the pod. So in the same worker pod, we have the worker container that I just mentioned. It runs the process responsible for training. The idea is let's also add this agent sidecar, which we can use to restart the pod in place on demand. And this is basically done by, if this agent sidecar gets a signal, doesn't matter from where for now, the agent sidecar is going to exit with a special exit code. Here I'm using 42, but it could be any number. And the pod spec is configured so that if this agent sidecar exits with this special exit code, it's going to trigger a restart pod. That is, it's going to force the pods to be restarted in place. And this kind of looks like the following in the pod template. For the worker container, we are basically saying if it fails, trigger the restart pod action. That is, again, restart the whole pod in place. Whereas for the agent sidecar, we have this restart policy action here, that if the agent sidecar exits with this special exit code, just restart the whole pod in place. So, okay, we have a way to restart a pod if the worker container fails. We have a way to restart the other pods in the workload on demand. Now we need a way to orchestrate. Like we have to basically fill this missing magic step of how we make sure that if anything fails, trigger all the other pods to also restart in place. And for this, you kind of have to go over the document. But again, just give like a very quick taste. Again, to make this introduction as brief as possible. We solve this basically by adding a new controller to job set and tracking the generation of the pods. So the basic idea is each pod has a generation. So pod A has generation equal to 1, pod D has generation equal to 1. They are all at this target generation, which means that workload is running fine. Something bad happens to pod A, it restarts in place. It notices that it restarted in place. So it says, oh, I'm no longer at the target generation. I'm actually at a new generation. And this is done by the agent sidecar. And since it just restarted, the new controller that we are proposing to the job set to job set is going to notice that one of the generations new. It's going to mark generation 1 as outdated, which is going to trigger the other agent sidecars to say, oh, hey, my generation is outdated. I'm going to restart in place. When all of them finish restarting in place, they will be all at this new generation, so that this generation can be marked as valid. And this is important because the agent sidecar is also adding this new barrier mechanic. And the basic idea is that instead of just like once the pod's finishing restarting, instead of just letting the working container start running right away, we kind of add this barrier. That is, we only allow a worker container to start running when all pods are ready to start. So yeah, this is my basic introduction. Like there's a bunch of things in this doc. For instance, I give more details about how this whole orchestration works. There's a lot of comments on the doc. You can check them as well. I go over the algorithm. Again, there's a bunch of
Giuseppe,
examples.
there are
Mhm.
a couple of questions. If
I'm sorry. I didn't see the the raised
No
hand.
worries.
Yeah, sure. I finished my introduction, so I'm more than happy to go over the questions. So I don't know who was the first
Michał
to.
was,
Yeah.
Michał Wysokiński was the first.
Yeah, I
Okay.
think I did this one. So yeah, I have two questions. So
Mhm.
Subset at the moment has like the restart counter, right, for the container restart. So what's going to happen when there's a pod restart or pods restart? So is there going to be another counter? Is it going to be the same counter for all types of restarts? So that's one question. And the
Mhm.
second question is, since you're mentioning like in place restart, I'm guessing
Mhm.
the expectation is that like if there's a restart, it's not going to be like a rolling restart, which will allow like the pod to go on another node, but rather like we want the pod to stay on the node, and we want just to quickly reinitialize and try again. So this would be like a mechanism to kind of have like a quick restart
Mhm.
or like software failures, not when like there's a problem with the node. And I'm saying this because in Q we have a mechanism that's called wait for pods ready, and its goal is to like react in case of hardware failures. So it would be good to kind of synergize a bit and to have like a good scenario for like different kinds of failures between queue and job set, where for example for software failures we propose like this configuration of the features and like if you're interested just
Mhm.
in software failures, if you're interested in just hardware failures, if you're interested in both types, because we've heard some feedback recently that like if you misconfigure like the current like the job sets like failure policy or restart policy, if you misconfigure it with like queues wait for pods ready, you can actually get into trouble that they
Mhm.
will actually like interact with each other, and you can end up with some restart loop or something like
Mhm.
this. Yeah.
Mhm.
So the
I.
counter thing, the first thing, and the second thing, yeah, what in place means and whether you're expecting like the pod to stay on the same node.
Mhm. Yeah, thanks for your question. Actually forgot to mention something during my introduction. During my whole introduction, I kind of only mentioned application failures. That is, a worker process just exits one, for instance, which triggers a pod failure. Um, but this design also handles infra failures because um, from the perspective of this design, a pod restarting in place, because again, it either was caused by application failure or because it was demanded to be restarted in place. This happening or a pod being recreated, that is, the node failed, the pod had to be deleted and then created and then scheduled to a different node. These two type of restarts and recreation, they both can be handled by this design because they're gonna and that's a cool thing about this restart pod action. Um, it's the same idea of recreating a pod, but just keep it running in the same node. So let's say a pod has to be recreated. The same thing is gonna happen. The agent sidecar is gonna start running. It's gonna check the target generation. It's gonna update its own generation. Um, this job set controller is gonna raid the generation of this new uh, pod, and it's gonna do its own thing, be either outdating the last generation or be it like raising the barrier for all agents. So to answer your first question, this counter applies to both like application failures and infra failures. Um, what else? Your second question was about, I guess, integrating with a job set failure policy and also this feature from Q. I'm aware of that, especially the job set side, the failure policy side. Honestly, I haven't gone to like every single edge case of a job set failure policy, but it should be handled. It should be possible to handle them as well.
Yeah,
Mhm.
I think we should collaborate on that, because like what happens in queues, like topology aware scheduling, is the reason why we've introduced like wait for pods ready, like which has like two modes of working basically. Like it either has like a node hot swap, like for a single container, for a single pod, and then it also has like the entire workload like being requeued and the placement being found again. The reason is that in topology or scheduling, we are applying specific node selectors for every pod, because that's the only way that we can guarantee like very specific placement for each of the pod. And like this mechanism like won't work with with topology aware scheduling, because like the node selector will stay on the pod, and if the other pod is kind of still there, if it's like a rolling restart, there will be like no recreation, it can be a deadlock, or if there can be like, this won't prevent it like from the node failures, because it'll have node selector to a specific node. So I think we should work on kind of aligning like how to configure both to get the best results, especially since like in GK, like we've heard about cases of misconfiguring like both of these and users running into issues. Yeah, thanks. That's and regarding the counter, like, is it going to be a single counter for container restarts and pods restarts, or is it going to be different counters?
It's what do you mean by container restarts?
Because right now, like, there's a single counter called like restarts towards max or something like this. And you have like two types of restarts here, so container restart and pods restart. So I'm wondering whether like they are both going to increment the counter, or there are going to be separate counters for like for I don't know, every pod, how many times it was restarted, or for entire pod.
It will be a single counter per pod. So if a pod got restarted in place, it's gonna increase the counter by 1. If the pod got recreated, it's gonna increase this counter by 1. And the job set controller can say, oh, what's the maximum value for all the pod counters? Oh, it's 10. Oh, is it like, does it exceed the max restart limit, setting the job set spec? Oh, it does, so just like fail the job set.
Okay. Thanks.
Next person is Andrei.
Yeah. So I think a couple of things. Thank you for this, by the way, for sharing. So first of all, I just want to ask one more kind of high-level question in terms of benchmarks you've done, right? So you said that without this feature, it takes like 1 minute to restart the pod. Wondering why this is happening and how do you measure this?
Yeah, so first question, how I measured. Basically, I literally created a cluster with 5,000 nodes, to be more specific, CPU node. Then I created a job set with 5, which is very similar to like the first spec that I have here in the document. It's literally a job set that creates one pod for each node, so 5,000 pods in total. And this job set is running like a dummy worker container, which is literally keep running. If I get a signal, just exit one, and that's it. So what I did is I sent a signal to just a single pod. It it exited one, which triggered this whole job set restart. And eventually all the pods are going to be recreated, all the containers are going to start running again, right? So I measure basically the time between the first container exiting one, and I did so by checking the logs. And after the whole restart is finished, I get the timestamp of the last worker container to start running again. So I basically get this end-to-end time. This is how I measure it. It amounted to roughly 2 minutes for 5,000 nodes. And sorry, you had one more question.
Yeah.
I
So
forgot about it.
I'm wondering why that is happening. Is it because
Mhm.
kubescheduler is a bottleneck when we have like more than 1,000 nodes on the cluster, or it's because we don't have image being pre-pulled on the nodes? I'm wondering why. What is the bottleneck
Mhm.
there? Because usually,
Mhm.
scheduler, the affect pretty quick, right? If you have less amount of
Mhm.
resources.
Mhm. Yeah, I didn't break down exactly like every single step of this end-to-end restart time. I don't think it's image pull time because like the images are small and I performed this test like many times, so by then the image was already cached. Uh, my understanding is this time is literally the overhead of mainly scheduling, like creating like 5,000 pods all at once and having them being scheduled to 5,000 nodes takes time. But also the overhead of like literally a pod has to fail, then to fail the job, then to the job set controller reacting to that, to then the job set controller deleting the jobs, so that it propagates to deleting the pods, so that the job set controller can then recreate the jobs and then recreate the pods again.
Yeah.
My understanding it's literally the overhead of deleting and creating a bunch of pods. It's not like image pulling or anything like that.
Yeah, because if I remember correctly, Kubernetes has specific settings which can check like the failures of the pod and then restart them, and we can adjust it. I'm just like want to understand if it is like the right solution for us for the long term to have in place container restarts. I don't know, like maybe we need some feedback from SIG scheduling here. I know, there is a new, as you mentioned, like there is a new API in the Kubernetes which allows you to do restart pod, right? New or to on failure restart API. So I want to understand like if it is the right way for us to have restarts on the container side, not on the pod side. And what is the bottleneck there? And what is the right way to fix it? Is it the right way to fix it is to restart the containers, or the right way to fix it is to work with the scheduler, the kube scheduler? To make sure it can quicker place the pods in terms of failures. So I don't know, maybe others have any thoughts on this.
I also want to just point out that we're not only addressing scheduling latency with the solution. Like I think being able to be sticky to the nodes has other benefits with checkpointing is like a big example, being able to maintain worker ranks. And then, image pulling, I know there's like other things you can do, but even reducing that overhead itself is also useful by being sticky to the nodes. So scheduling latency is like one of the things we want to address with in-place restart, but there's also other benefits.
Yeah, I think that makes sense. I kind of like feel the stickiness to the node can be solved with the node selectors and topology over scheduling that we've been talking about. So we make sure those group of pods will always be scheduled to this particular node. But not sure like what kind of problems we really try to solve here.
How would you, at runtime, continuously stick a pod to a node? Like you need an orchestrator to do that, right? Like the whole premise of in-place restarting a container when a container fails is the same thing here, right? Like the thing is we're trying to do it at a distributed fashion. Like imagine the whole job as like, a super pod, right? You just want to restart it in place.
Yeah, I think that makes sense. Basically without pod selectors, right, you're talking about.
But I mean, going back to the original question about like topology, that's a very valid concern, right? Like how do we ensure that topology-aware scheduling continues to make sense after you restart in place. And I think for that, I think it needs to be handled slightly separately. So there needs to be some sort of, I don't know, like a policy that says, yeah, restart in place makes sense now because the topology hasn't changed. Everybody can continue to run where they are. And then in other cases where, the scheduler decided that the failed pod, like there's probably one or two pods that failed that triggered this whole thing and needs to move somewhere else. All the others could continue to run where they are. But if those pods were moved somewhere else that would break the topology, then we need to trigger a recreate and trigger a rescheduling and trigger a replacement according to, the topology.
Yeah, that makes sense. I just want to give you, Michael, as well to ask some questions. Just maybe a small one in terms of the counter. So we will not use the backoff limit, right, to count the number of restarts. So the counter will be separate from this API. Is my understanding correctly here?
I'm not sure because for this specific use case, the specific pattern of job set, and I don't even mean in place restart itself. I mean like currently how I see a lot of users using job set. I assume backoff limit is equal to 0. So it's not used as a counter at all because I want the job to fail if any pod fails to trigger the job set restart right away. Yeah, but I plan to use the max restarts counter of job set to count job set restarts.
Yeah, I think I remember like we've been discussing there will be several layers of API on the job side, on the replicated job side, and also on the job set side. So there are 3, I think, layers of restarts that we should see, and like the question like where those container restarts should go towards which API. I guess right now it's just to nothing, right? We just have this generator label that we have. Yeah, I don't know. I think there are a lot of things we probably need to talk about in terms of how to track, like how to limit the number of container restarts, in place restarts. But anyway, yeah, Michael, go away.
Okay, so my question was maybe already answered and thought through, but basically similarly as Michał Wysokiński, I'm wondering if you are solving the problem of not just failures of containers, but what happens if a entire pod fails, let's say one in the workload, because then you say about the generations, but if the pod is recreated, then I think it will have still the replacement pod will have generation 1 probably, I assume. So we will not bump the generation. So maybe it's worth testing if this, maybe you've already tested. But just trying to make sure that that this is thought through. Yeah, and basically another question is, I saw that the cap that you mentioned is already alpha in the core Kubernetes, so that's very nice progress that you are using. And I would like to ask about the progress in JobSet. So you mentioned some preliminary results. I'm wondering if there is already, let's say, some PR, or what are your kind of delivery timeline for this feature?
Yeah, so for your first question, again, like, sorry I didn't explain it during my original introduction of this design, but just to make it clear, this design also handles pod failures, as in if a node fail because of an infra failure, the pod's gonna eventually be recreated, and this is handled. The design handles this case as well, because one thing that I want to make it clear is that pods being restarted in place and pods being recreated, they are very similar process from the container's perspective. The container is gonna terminate and they're gonna be started in order. So What I mean by this is if a pod gets restarted in place, the agent sidecar is going to be roughly the same. The first container to start running, it's going to do its own work. And this is also true for when a pod is recreated. The agent sidecar is going to start running, it's going to check the target generation, calculate its own generation as target plus one, and everything's going to work right. So yeah, your first question, pod recreations, this design handles. I tested it in my prototype, it works. Yeah, so you asked more questions. I think you also asked about like the status of this design,
Yeah,
of this
basically
feature.
timeline.
Yeah, like at this right moment, like right now, I have design, it's shared, everybody can see in the jobset repo, and we are going through discussion points, so especially on how we can make these generation counters available. Like a few options is like, oh, make it available through a pod notation or make available through a config map. So we are ironing out these details. I made a prototype for the benchmark and also to iterate the design. My plan is once these details are ironed out, I just create, let's say, the official short-term implementation of this feature, which will not rely on the new restart pod action because um, um, it's planned to be released by 135. So before then, we want to get more feedback for the solution. So that's why we have a short-term implementation planned. And of course, once the restart pod action becomes available, also creates the long-term solution based on that. Yeah, and like time-wise, the plan is to have the short-term solution done by the end of the year. And the long-term solution, start to work on it once restart pod action is available, which if it's 135, it should be available as alpha, but available anyway at the start of the next year, like literally January. Yeah. Okay. Does that answer all of your questions?
Yes, thank you.
And yeah, Kevin raised a fair concern. We have more topics to go over, and we have like 15 minutes left for this meeting. Maybe we can leave Michal last question.
Yeah, we can either like chat offline or we can like chat on the design. That's fine. Let's progress with the topics.
Okay.
I think maybe just some small point. Like I think getting a feedback on config map controller, I think also be valuable. Like maybe let's follow up this in the cap and see if there are any kind of alternative to have, rather than having config map per pod. But we can discuss it offline as well. So thanks for this.
Yeah, thank you all for your comments and questions.
Thank you, Giuseppe. We'll do a very small shift in the agenda. Wojtek wanted to make a short announcement, and then we will move to Michał. Wojtek?
Thanks. So yes, I got 1 minute, so like super quickly. I hoped I will be able to present a little bit more in a little bit more details the proposal. I'm happy to do that like in the next meeting. But I wanted to give you a heads up that we have a cap open for that is introducing the concept of the workload, and on top of that, as a step towards introducing like the gang scheduling. So the cap and the wider doc with more context and a little bit more like future thinking are linked to the notes. So like if anyone wants to share your feedback or bring concerns, I'm happy to like chat on Slack or in the next meeting or whatever. So yeah.
Just maybe a good question. So in terms of timeline, when we're planning to finalize feedback, and what is the right now place for us to leave feedback? Is it PR?
I think the PR, either the PR on the doc. I think we are trying to move all the discussions to the PR now. So like please
should we make doc read only and ask folks to leave comments in the PR, because I saw like there are multiple comments in the different places.
Okay. Let me try. I wanted to wait for Eric also to get back from his vacation. Like I will discuss with him too. But yes, I think that generally, like, if you have new comments, like, let's try to add them to the PR itself, and we will try to resolve the comments in the doc, like in the background too. Okay.
Okay. Michał Woźniak.
Okay. So I want to share my screen a little bit. I cannot share. I have disabled share.
I made you a co-host. You should be able to share your screen now.
Thank you. It works. So basically, I created a small doc to summarize our plans for Q graduation, as we are getting like internally, but also at conferences, questions about the graduation of Q. We've decided to basically move forward with these plans. This is just like the overall big picture at the moment. So the first step is to graduate topology we're scheduling to beta. And this will happen in 0.14. All of the major PRs are already merged. So we are good to go. And so this will be like next week release. And this will mean that all the APIs in Q are now beta, V1 beta 1. So we don't have any more alphas, and we would like to use this moment to move everything to V1 beta 2 as the interim step between V1. So basically, we have an issue about wish list for the API changes to V1 beta 2. So I would like to encourage everyone who is interested in the list to take a deeper look. We don't have time now yet, but I just reviewed the list myself and annotated, let's say, with the green checkbox that it's like already done. The star means that we internally had the discussion, and I looked at this, and in my view, this is worth doing, but not done yet. So something that will need to happen one way or another. And there are still open questions. I have already got some feedback internally about them, so I will be proposing after the 0.14, and once I can fully focus on V1 beta 2, which will be 0.15, like summary of the proposals. But one thing is particularly not clear to us to me after the initial look. So let me share this, bring to your attention this one open issue about the API, because this was raised by Marcin, I think, but also by Yuki and others, that we should probably deprecate the local queue flavor status in V1 beta 2 so that we can remove it, because it's kind of anti-pattern. So let me explain. So a while back, we had the cap, and we added to local queue, maybe not everyone knows about this, but to local queue status, we added the field in this cap that was like legitimately reviewed and approved, etc. But we added the field that its purpose is to expose the information about cluster scope APIs, like what are the flavors, what are the resources, what are also now the topologies available. And basically, the concern is that it's not like the role of the status of the local queue to expose this information. So I would like to ask you if you are, let's say, if you have any objections against deprecating and eventually dropping this API. Like, do you find it like really still useful? If no objections, then we could probably drop it even without replacement. If you feel a need for this API, maybe in your company you use it, then it will be good to let us know so that we can either plan the work on replacement or consider keeping the feature because it's useful. So basically, I will like to hear feedback either during this meeting or under the issue. Like, please don't remove this, is super useful, or I agree that it should be removed, and I want to work on replacement, or no one cares, then we just, I think we can deprecate and remove. Okay, so that was my, I will welcome if there are any comments on that now.
Kevin?
Yeah, I can't say for local queue flavor status if I know of anyone using that one, but I wanted to ask about, so for our side, we have quite a lot of users using V1 Beta 1, and one of the challenges we're finding with keeping up with queue is understanding, like, from release to release, like what is upgradable. And so like if I have cluster queues created in 0.14 and then 0.15 comes out, like are we going to have a clean upgrade path from V1 Beta 1 to V1 Beta 2, or are we going to just effectively ask people to recreate their resources for 0.15?
Okay, so indeed that was our strategy when migrating from alpha to beta, so that we always in like the release notes advised how to migrate manually if you need to. From the discussions, like I haven't found yet, we had some internal discussions that we should probably have conversion webhooks, basically to automate the upgrade to V1 Beta 2.
Okay. Yeah, I mean, that would be good. And then, I mean, that's kind of, if that's possible, yeah, that would be ideal. And then same for V1 Beta 2 to V1. I remember there were some APIs like dropping the cluster queue resource groups, which I thought would be a challenging one to do a conversion webhook, but I guess we're not going forward with that change anymore.
No. That was my kind of getting to the community to hear feedback. Similarly, as now I'm asking about the status, I got feedback that it's very useful. And in the meanwhile, we also had a user like internally asking for which we found that it's still useful in combination with the configurable resource transformations features. So we decided to keep it. I think I even closed the issue by now.
Okay. So for V1 Beta 1 to V1 Beta 2, the plan would be a conversion webhook, and we would keep V1 Beta 1, correct? For like a release or two and then drop it?
Yes, that's the plan. I have not done this yet myself as a maintainer of Q. This is for me like new learning, so I'm going to investigate. But maybe if you have experiences, maybe Andrei or Yuki from other projects, then I will love to learn more how to do that. But basically, that's my current understanding that yes, we will introduce the conversion webhooks. We will maintain V1 Beta 1 for time being until we move further with the APIs.
Yeah, that sounds great. I mean, thank you for this.
Michał?
Yeah, quick comment because I don't know if it was said out loud enough that like we also discussed like an ambitious goal of undergo like an official like Kubernetes API review for V1. So like we would be super curious like to hear like your feedback about that, because that would allow us to move from X K8SIO to K8SIO and to be like to have official approval like from the API reviewers.
So I'm happy to, I can start that thread with some folks. I know on my end, we've had some people on our OpenShift API team reviewing the Q APIs. If you're interested, there is a Cube API linter that you can use called Kai, Kai. That is a Golang CI plugin that you could run that linter on the Q API just to see if it conforms to at least some of the Kubernetes API like requirements. And then I can also reach out to see if we would want some people to help review it for V1.
Perfect. Yeah, I
might be yeah.
I think what we've discussed like with Michał and Marcin like very preliminarily was to try to clean up like as much as possible like for like obvious cleanups for V1 beta 2 and then to go from V1 beta 2 to V1 to have like the official K8s API review.
Yeah, if you guys want, I can take on at least. I've been interested in trying to incorporate the Kai linter. I can see if I can have it part of in a PR to include that. I know the person that can ask, so we could at least get the linter to see like what APIs are not conformant to that linter. This has been rolling out in upstream Cube also to help with API reviews. So yeah, I'll file an issue for that one and I'll work with someone on that.
Awesome. Perfect. Thank you.
Okay, any more questions to that topic? Yuki?
Yeah, let me read just a comment for Cube API Reader. So as far as I know, Cube API Reader has a lot of linked rules. However, core Kubernetes does not introduce all linked rules. Some of rules are picked up for the core Kubernetes. So yeah, I totally agree with introducing Kube API Linter. However, I want to align with core Kubernetes pickup policy or something. Yeah, just comment.
Cool. And we are slightly over time, so Aliapi, please try to be short.
I just had a question. It is amazing to get reviews from core Kubernetes folks. I just had a moving forward kind of question, as in, let's say if we are once we have that and once we make the APIs part of the kits.io domain, how would the introduction of new APIs look like? Will it then go through the normal review process of CAP and core Kubernetes, or will we still follow the CAP process that Q has right now?
Michał?
We have not done a decision yet, but I think we cannot basically afford in Q going through Kubernetes review every single time. So I think this will remain the process just in Q, like in any other projects. And I think for 6 projects, it's not really even necessary to go through Kubernetes review. It's like nice to have. Maybe we can win a reviewer from the Kubernetes core, but it's not really like a blocker, I think, for any graduations. We will strive to do that, but I don't know if okay, it's not a well thought through answer yet, but at this moment I think we will just try our best, but it's not exactly sustainable to every time for every feature ask Kubernetes reviewers.
Yeah.
Okay, I guess we run out of time. We have one outstanding agenda item that we are unable to follow up right now, so it will fall to the next meeting. Thank you all for joining, and see you again next time. Take care. Bye-bye.